So now let me consider one more example, that is f of z is equals to z raised to n, where n is positive integer. Okay, so here again, as I told you, here I have to consider this as w is equals to f of z is equals to u plus I into v. So for this, okay, so z is, we can consider x plus iy, or we can consider r e to the power I theta, like this. So if we go for this one, I'm going, z raised to n is there, so it will become x plus iy raised to n, so which will become difficult for us to separate real part and imaginary part. Okay, so therefore what we are going to do, we are going to write it in polar form. Means, how can I rewrite? In place of z, r e to the power I theta raised to n I am going to write. Okay, so now this is equals to, I can write r raised to n e to the power I theta raised to n. I can rewrite it as r raised to n e to the power I n theta, like this. Okay, if I simplify this, means r raised to n e to the power I theta, I can write it as cos theta plus I sin theta. So here I can write it as cos n theta plus I sin n theta with the help of De Moivre's theorem. Okay, so now I am going to separate real part and imaginary part, that is r raised to n cos n theta plus I r raised to n sin n theta. Okay, here it is n theta. Now r raised to n theta. Okay, now this is u is equals to r raised to n cos n theta, and imaginary part v is equals to r raised to n sin n theta. Okay, so I need to differentiate, since it is in polar form, u with respect to r partially. So I'm going to get n r raised to n minus 1 cos n theta. I have to keep as it is because I am differentiating with respect to r. Similarly, u I have to differentiate with respect to theta. So what I am going to get here, yeah, this r raised to n as it is, cos theta differentiation is minus sin n theta into n, so which I can write it as minus n, okay, r raised to n sin n theta. Okay, so similarly for this v term, okay, so how can I rewrite? So differentiation of this v with respect to r is nothing but v subscript r. So n r raised to n minus 1 sin n theta I have to keep as it is. Okay, again I have to differentiate v with respect to theta. So what happens? This r raised to n I have to keep as it is, and sin differentiation is cos n theta into n, so which I can write it as n r raised to n cos n theta. So this is what we are getting. So then CR equation in case of polar form we are looking now. Okay, so here CR equation in case of polar form, what we have, r u subscript r is equals to v theta, and r v subscript r is equals to minus u theta, and here u r is equals to what we have, r as it is I'll write. Okay, u subscript r, what we have n r raised to n minus 1 cos n theta. Now if I simplify this, n as it is, okay, r raised to n minus 1 cos n theta, okay, or this one. If I include means r and n as it is, I'll write. Okay, so this bases are same, power I have to add, so r is to n I am going to get cos n theta. Okay, so which is nothing but, so here v subscript, this is nothing but v subscript theta, isn't it? So this is v subscript theta, and similarly r v subscript r, we have r as it is, v subscript r, what we have, n r is to n minus 1 sine n theta. Okay, so again this n I'll keep as it is, r into r is to n minus 1, okay, sine n theta. Okay, so this n as it is, bases are same, okay, means power I have to add like this, sine n theta, minus 1 plus 1 gets cancelled, n r is to n sine n theta. Okay, so this is r v subscript r, so this is nothing but minus u theta, u subscript theta, isn't it? So since this f of z is equals to z raised to n satisfies, okay, satisfy CR equation, okay, this f of z we call it as a analytic function, analytic function. Okay, now we have to find its derivative. To find the derivative, what we have, dw over dz is equals to f dash of z is equals to e to the power minus I theta, in case of what, in case of polar form, into bracket u subscript r plus I into v subscript r. Okay, so e raised to minus I theta, so u subscript r, what we have, n r raised to n minus 1 cos n theta plus I into, okay, so v subscript r, what we have, n r raised to n minus 1 sine n theta. Okay, so then I can take this n r raised to n minus 1 term common, so n r raised to n minus 1 into e to the power minus I theta, what remains inside the bracket, cos n theta plus I sin n theta. Okay, so now this cos n theta plus I sin n theta, how can we rewrite, n r raised to n minus 1 e to the power minus I theta. Okay, so this I can write it as e to the power I n theta, isn't it, cos n theta plus I sin n theta. And now n r raised to n minus 1 as it is, so e to the power, I will take this I theta common, this what remains, 1 minus n we are getting. Okay, so now further if I simplify this, n as it is, okay, so r raised to n minus 1 also as it is, e to the power I theta whole raised to, I can write n minus 1, because of this case raised a to the power n raised to m is equals to, I can write it as a raised to m into n. Okay, so therefore n, so these two I will combine now. Okay, since the powers are same, so r e raised to I theta raised to n minus 1, so which I can write it as a n z raised to n minus 1, so this is what, f dash of z. Okay, so this is, if I differentiate what f of z is equals to z raised to n with respect to z directly, okay, dw over dz, so I'll get n z raised to n minus 1. The same thing we are getting by using CR equation also. So this is the this is how we are going to solve the check the and a function whether it is analytic or not. If it is analytic, then we are finding their derivative with the help of CR equations. Thank you.